Great.
Hello.
Hey, how are you?
Pretty good.
Good.
All right. First of all, happy International Women's Day to everyone. I hope you all had a great one already. Hopefully, to make it a bit better.
Yep.
Okay. Let me.
Great. So if you want to go on and share your screen.
Yes. All right.
So
Can you?
Misho is talking about structural concepts while surveying buildings of historical and cultural significance. So I'll pass over to you and good luck.
Okay. Hopefully, you can all see and hear me. All right. Can you?
Yep, I'll find.
All right. So let's talk about monuments of historical and cultural significance, especially some methods about their preservation. Okay, so a bit about myself, first of all. I'm from Bulgaria. I'm a fourth year civil engineering student. And as you can see, this here is a photo of me in an ancient tomb. Actually, it's almost 3,000 years old. And we're going to talk about that later. But I hope some of you or most of you are familiar with the seven ancient wonders of the world. And unfortunately, six of those are destroyed. Only one of them is present now, the Great Pyramid of Giza. And I would like to first start with, so if this is on the left, the Pyramid of Giza, and on the right, the great city of Shanghai today. And we're going to talk about what actually defines a structure or a building as historically significant. How are we to determine the necessity and how we actually approach the topic, and why should we? Okay, so first of all, this is an engineering problem, most of all, because this is what I'm concerned with, but it is also a multidisciplinary challenge as well. There are so many different specialists involved in preserving a building or a monument. You have archaeologists, artists, historians, you have biologists, chemists, craftsmen of all sorts, stone workers, carvers, even soil and material sciences, and they all contribute to the preservation of something that is inherently ours as members of the world, a cultural piece of monument that is vital for everyone to witness and marvel at. It serves also a great deal of educational purposes too, and it helps to facilitate economic, tourist, and progress technological growth in general. And so, first of all, a bit about background about historical monuments of cultural significance. Here on the left, you could see a photo of the first ever dated ornate gold found in Bulgaria. And as previously mentioned, I'm Bulgarian, so I'm quite proud of that. It's really intricate. It's almost 9,000 years old. And I think it's just great that even people that were way before the ancient cultures like Egypt, Mesopotamia, the Greeks, the Romans, the Chinese, like even before that, they managed to create something that is this astonishing. And we're going to take a look at a specific civilization that is not really that well known by the common public. It's the Thracians. They are a civilization that was located around the Balkans and Asia Minor, so the modern day countries of Greece, Northern Macedonia, Bulgaria, Turkey, Romania, and some others. And they are, as mentioned, quite ancient. Their origin is really disputed, but they were deeply connected to the Greeks and the Romans, though they were quite different. They had their own culture, religion, beliefs, and matrimonial and burial cultural practices. So we're going to take a look at some of their buildings, and here on the bottom you could see two of those, two tombs and their respective mounts, as well as a ornate gold element that I believe is really beautiful, and everyone could relate to liking that, even though if you're not an engineer. We're going to take a look at the study of the form, the type and the condition of the materials, as well as the working mechanism. And if you imagine a Jenga tower, if you remove the top piece, then what will happen? It won't topple off, correct? Because it's just a small portion. But even a small piece removed from a particular point in the middle could topple off the tower. And this will come really helpful as an anecdotal idea and a concept later when we start looking at some specific examples. The first one is Alexanderville. It's a village in Bulgaria, and there is this really large mound quite near it, and it's been unearthed in the year 2000, actually quite recently. So we didn't know it existed before that. And as you can see from the photos here, it's unique in the detailing of the frescoes and the artworks. And as I know, some of you are really doing great in like history and art, so you could just fascinated the creations that are 3,000 years old or more. But there is a problem with this one. The lack of a comprehensive polydisciplinary study has led to a particular damage to the frescoes and the artwork as well, and is compromising the structure itself. So what has happened is during the excavation, and going on the next slide, I'll have the freedom to actually show you a bit better. Hopefully you can see here on the picture on the left, this is the burial chamber. This is the main portion of the tomb. And what happened is when the workers in the year 2000 entered, they excavated and then created this gallery here, indicated in yellow. So what happened is they removed a middle portion of the Jenga tower, and what actually happened is that the mount is starting to collapse. So obviously this is really bad. It allows for the penetration of water, which destroys the integrity of the building and the mount itself, and damages the frescoes, which are portion of a really important cultural heritage preserved by UNESCO. And I don't know if you're familiar with the Venice Charter, but it's basically a charter clause that says and defines what makes an artwork really important. And yeah, it's been defined there. So this is really problematic. And we are actually proposing a new sufficient engineering modeling and analysis method to solve this problem and to help remedy the situation. So in order for us as engineers to preserve the integrity, to actually build up the Jenga tower once more so it stands up the test of time, and allow all of those other specialists to work there and investigate, and eventually to allow tourists and people from all around the world to actually witness something that is as good as this one. So yeah, there is a quite problematic portion of effects called anthropogenic. They come from humans, human-made impacts, and they include the gallery that was shown before, as well as the compromisation of integrity from ditches and vegetation introduction. And this can relate to biologists and chemists as well. So we have a really large team compromised of all of those specialists working together, and we're trying to remedy those anthropogenic effects. The second portion of the research is related to a different site in Mount Tepe, and it's a different tomb, a different type. It's a beehive. Doesn't really matter what exactly this is. It's just a classification. Mycenaean type as well. This is a different classification, and it's one of the largest actually discovered in the Balkan Peninsula. Incredibly rich, of great architectural importance, and it stood the test of time marvelously. It's just so really well preserved. I hope that you could tell that from the pictures here. And yeah, it's actually older both in excavation and dating as well. It's been unearthed almost 100 years ago, but it is preserved in its authentic environment. So only a portion of the entrance is compromised, which if you go back to the already well-defined example of the Jenga tower, removing a small portion of the top wouldn't compromise the structure. So that is the case here as well. The entrance is a bit destroyed, but that's not a problem to the artworks or to the structure itself. There are some traces of damage, but they are mostly connected to small seismic impacts. And the current state is, yeah, as mentioned, some changes in the conditions that include the seismic effects. There is as well damage to the bulk body, which has a negative consequence, but this is not as problematic as the first example. And in the future, we propose a more thorough study, a more comprehensive analysis that would include inviting different specialists from different fields of engineering and sport to actually investigate the flexibility and the fragility of the elements, so we would actually know what to reinforce and how to proceed with preserving the mound. But I hope that you could see from the images here that the state is actually really well preserved. And yeah. So in conclusion, we as engineers are mostly focusing on the reliability of the engineering studies, removal and remedification of previous harmful measures, as well as preservation and meeting the new established criteria for reinforcing the structure, strengthening by using the original technique. So this is where historians and artists and archaeologists come into play. They tell us how those things were built in the past, and we implement that as the new mechanism of working. And we monitor and prognose how the structure will behave in the future. As long as it's stable, we are happy and we just help it survive the test of time. Here, there is a bit of a conclusion about the destructive processes, if you are interested in that, but we are following the four main steps of the investigation: preservation, improvement, and longevity. And all of those were previously kind of described, but just to briefly summarize, the investigation takes the artists, the historians, all of those people to actually investigate. Then we as engineers come in, we analyze, we do our thing, we do our modeling, and then all of the craftsmen come into play. They improve, and hopefully that leads to the longevity and durability, so everyone could actually witness and learn about that. And I think that's pretty great as an outcome, as long as the structure survives. And yeah, thank you for the attention. You could find the full published paper in the link just here, or just by following me on LinkedIn. I'm happy if you guys have any questions, reach out. That's perfectly okay. And yeah, I welcome any questions.
Great, thank you so much. Again, so I'm a historian, so I'm naturally super interested in this. But I loved that discussion there of the way in which you're bringing your subject into that kind of really genuinely multidisciplinary approach to saving these historical sites. It's fascinating. So we've got a couple of questions here for you. The first one is, can you use what you've learnt here to save whatever might be our future great wonders? So whatever buildings we currently have that then will become a great wonder, can you use that?
Yeah, most definitely. I believe that learning from past mistakes and learning from what the ancient people and the ancient civilizations have actually obtained as knowledge is vital. This is how we progress. This is how we go forward. And no one knows everything. No one starts from nothing. We already have, as long, like even at the very beginning stages of an engineering degree, you already have so much knowledge regarding engineering. And this comes from other people's experiences. And I think that just by investigating different structures of the past, you could implement that for preservation of cultural heritage all around the world and preservation of future cultural heritage as well.
Yeah, cool, great, thank you very much. And then a second question was saying, looking at the picture you had at the start and then the theories, what does your work look like in practice?
Okay, so that is a really broad topic. I guess really depends on what portion you are focusing on. But mainly what happens is you have a lot of in situ. So in situ meaning field work. You go there, you just investigate visually. First of all, this is the very first step. And then kind of you become familiar with documentation, different plans, different engineering blueprints, solutions, which are most of the time, especially for some remote sites, missing or incredibly insufficient. So you have to reestablish them or find them in, like in just like lost archives, or you go around, you ask people that were involved with that. So you investigate the methodology that's been implemented during the excavated lifetime of such a monument. And then what you do is, well, you start modeling. there are various different methods of modeling various different things. So you could model the structure, you could model the microclimate, which then gets involved with AI. You could implement biological, biochemical methods, and this is more in the lines of work of biochemical engineers and whatnot. And then you start to look at the mechanism, the working mechanism. So yeah, I really like that metaphor with the Jenga tower because it just makes it into perspective. And we start reestablishing the Jenga tower, and you manage to make it whole. Hopefully, I mean that's not always that easy, but most of the time we manage to pull some rabbits out of our hat to make it work.
That's great. Yeah, it sounds so cool, so cool. I think I'm envious of you getting to go off and do that. And that I actually I really like that explanation of working through things like in the archives and the blueprints, which is actually quite laborious historical research, and then applying that into the built environment is so cool. Thank you very much. So can we again give Misho a round of applause, please? And then if you want to stop sharing your screen.
Okay.
Thanks very much. Great, good job.